Okay, today we're going to talk about parabolas. Parabolas with their vertex at 0, 0. And we see before us the definition is the parabola set of all points in a plane that are the same distance from a fixed point F, called the focus, as they are from a fixed line called the directrix. New terms, focus and directrix. The focus is very similar to what it has been up until now. The directrix is totally different. It is a line, and as you can see from my graphic below, the directrix is right down here, and that directrix is, again, by definition, we have to have the same distances going on here. So here's what's happening. If I count from my vertex, which is right here, up to my focus, it's 1, 2, 3, 4 boxes away. If I count from my vertex down to my directrix, 1, 2, 3, 4, it's 4 boxes away. So the distance here must equal the distance here by definition. So those two are equal. They are both 4. So we have the focus up here, and then we have the directrix down here. The focus is always inside the parabola. The directrix is never touches it. Okay, never touches it. This is a line through the focus, and perpendicular to the directrix is called the axis of symmetry. We talked about the axis of symmetry before, and the point of intersection of the parabola and the axis of symmetry is called the vertex. Remember, axis of symmetry, we fold it in half on that line, we get 2 equal parts. So you can see the axis of symmetry is here, it's this red line. And our vertex is right there. It's where this line and the parabola come together. Okay, now, remember we defined A, B, and C before. Well, the only one we have to worry about now is A. And A has a new definition. It's right here. It says A is the distance from the focus to the vertex and from the vertex to the directrix. So this is A, and this is A. So in this case, A is 4 in both situations. Okay, I'm going to let you kind of soak that in for a second here. And let's see what's next. Okay, there are 4 equations for the parabola. 4 equations for the parabola. They are going to open up, down, left, and right. This one is going to open up, this one is going to open down, this one is going to open right, and this one is going to open left. And it looks like this. If it opens to the right, it's going to go like this. If it opens left, it's going to go like this. Up is going to go like that, and down is going to go like that. So now you know what the 4 of them are going to look like. Okay, I'm going to pause here for just a second. I'll be right back. All right, so since we have those 4 equations, we know this one opens right, this one opens left. I'm going to zoom out a second here. There we go. This one opens up, this one goes down. On your notes page, which way does this open is the first question. So how do I know? Well, notice that when it opens right and when it opens left, the y is squared. When it opens up and down, the x is squared. Okay, so that should tell me this opens right or left. This opens up or down. This opens right or left. This opens right or left. Okay, so how do I know if it opens right or left? Well, I'll tell you what, let's do this one first. We know this one opens up or down. Okay, so I take a look. Okay, they're both x squared, so that's all right. Now, what's different between these two? This one has a negative sign in it. This one does not. Does this have a negative sign in it? No. Therefore, this one opens up. Same thing is true over here. When I took up the rights and the lefts, okay, the squared is y squared. This one is positive, this one is negative, this one opens left. These aren't in the same format, so let's get the y squared by itself. So 4y squared is negative 5x. So y squared is negative 5 over 4x. It's negative, so it opens left. I take this one, I rearrange it. Negative 6y squared is negative 3x. I divide both sides by negative 6. I get y squared is 1/2 x. This one is positive. This one opens to the right. Notice how we did that. Again, we look first for which one is squared. If it's x squared, it opens up or down. If it's y squared, it opens left or right. If it's positive, it's up. Negative is down. Positive is right. Negative is left. All right? Good job. All right, let's graph one. Okay, so we know the focus is at 0, 2. So 0, 2. I know the vertex is at 0, 0. Remember the definition of A? A is how far is it between those two things? It happens to be 2. Now, I went up from the vertex to get to the focus. The opposite of up is down. Therefore, I'm going to go down to find my directrix. My directrix is a line. My directrix is a line, and in this case, it's a horizontal line. Since it's a horizontal line, it is a y equals. So my directrix is y equals negative 2. Now, here's the fun part. I take that 2 and I multiply it by 2 to get 4. Starting at the focus, I go 1, 2, 3, 4 out. I go 1, 2, 3, 4 out, and I draw my parabola through those 2 points, just like that. How did I know it opened up? Because my focus was above my vertex. When the focus is above the vertex, it opens up. Does that kind of make sense? Okay, let's take a look at number 6. Okay, in this case, my focus is at negative 4, 0. 1, 2, 3, 4. Negative 4, 0, and my vertex is at 0, 0. Bells should be going off in your head. I'm 1, 2, 3, 4. So A must be 4. If I went left, I'm going to need to go right because those are opposites of each other. 1, 2, 3, 4. That is going to give me my directrix. This time it's a vertical line, so my directrix is x equals 4. I take 4, I multiply it by 2 to get 8. From my focus, I go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. And I draw my parabola. This one's pretty flat, but that's okay. That's my fault. And there's my parabola. Not too terrible. Okay, let's take a look at the next one. Okay, my focus is 0, negative 1. 0, negative 1. My directrix is y equals 1. That's right here. Okay, what is exactly halfway between them? 0, 0. So my vertex is 0, 0. What does that make A? Well, the distance here is A. The distance here is A. Both of those look like 1. And 1 times 2 is 2. So I'm going to go 2. Why am I going left and right? Because I need it to open down. Opens down. since the directrix is on top, because it always has to go away from the directrix. So here's my parabola. Not so horrible. Let's try one more. Okay, the directrix is at -1/2. You know what? There's no scale, so guess what I'm going to do? I'm going to make this -1/2. Oh, it says x equals. That would be y equals. X equals goes like this. Here's an x equals. Okay, here's x equals -1/2. My vertex is still 0, 0, which means my focus is going to be at the point. Focus is going to be at 1/2, 0. Does that make sense? I hope so. Okay, if that's the case, I multiply that by 2 to get 1, which is 2 boxes, and I'm going to go to the right because my directrix is on the left. Opens right, since directrix is on the left. So far, so good. All right, I think we got one more page here. All right, we've got some equations to write. It says, find the vertex, focus, and directrix of each parabola, and which way does it open? All right, well, let's go back to those 4 equations. Give me a second here to find those. Here they are. All right, I'm going to slide those underneath here. Does that help just a smidge? Okay. This one is x squared, and it's positive. So x squared and positive, this one opens up. That was a really bad up. All right, that one opens up. Okay, why don't we run through all of those really quick here. This one is y squared, and it's positive. Y squared and positive opens to the right. Okay, this is x squared and negative, so this one opens down. And this one is y squared and it's negative, so this one opens left. All right, so now I'll tell you what, there's a hint today. All the vertices are at 0, 0. So we're going to quick fill those in. All right, got those. So now the trick is I have to figure out what A is. I have to figure out, I'm going to move this up a smidge. I didn't realize I had this much room. There we go. That helps a little bit. Okay, I need to know what A is. Well, let's take a look. It says x squared is 4y and x squared is 4ay. So doesn't 4y equal 4ay? Can I divide both sides by 4y? I get A equals 1. Okay, we know A is 1, and we know our vertex is at 0, 0, and we know it opens up. So 1 unit above 0, 0 is 0, 1. And the directrix goes the other way. If this went 1 up, this is going to go 1 down. So it's going to go through the point 0, -1, which tells me it's y equals -1 is my directrix. How did I get the y equals? Where's it at? It's in the y position. Take a look here. Again, I know that x or y squared is 4ax. So again, 8x is 4ax. I divide both sides by 4x. I have an A of 2. We know it opens to the right. Okay, my brain just totally lost it. No, that's right. I want to go 2 units to the right. 2 units to the right of 0, 0 is 2, 0. So 2 units to the right is 2, 0. 2 units to the left would be -2, 0. You see where I'm going. Where is this? It's in the x position, so my directrix is x equals -2. Okay, let's try the next 2. All right. So we know x squared is 4ay, so Negative 4y is negative 4ay. Again, I divide by negative 4y. I just want a by itself, so I get a is 1. I go down 1. Down 1 from here is 0, negative 1. If I go down to get to the focus, I go up to get to the directrix, so that would be the point 0, 1. So in this case, my directrix is y equals 1. Again, I know it's y equals because it's in the y position. There's my directrix. And the last one. I know negative 4ay is, bad. Negative 4ax is negative 16x. I divide by negative 4x. I have a equals 4. 4 units to the left of 0, 0 is 0, negative, I did it again, is negative 4, 0. 4 units to the left, so this would be 4 units to the right, so it's going to be at the point 4, 0. So it's in the x position this time, so x is equal to 4. And that is how we do parabolas.